One is whether the branch will be taken or not taken. So that is the comparison statement, right? The C the CMP statement, which we performed on CPU simulation also. So if this comparison statement, so one ALU used in the execution stage, if you remember, that is used to check the comparison statement, comparing the some value like R1 and suppose 5. In generally, if you write that if R1 is equals to 5, then perform something, right? So this is the condition. And second one is if it is true, then which statement is going to be executed, whether these statement or outside. So that we call branch target address, right? So first condition evaluation, second one is the target. So the target in our CPU lab, we use the label, correct? The level 1, level 2, level 3. Did you remember that? So level is the target, correct? Yeah. So I'll directly come to the point. In 2-bit saturating counter in branch prediction, this graph is very important. Just understand. There are hardware component. The node 2-bit saturating counter means 2 to the power of 2 is equals to 4 states. There will be 4 states. So what are the combinations? 0, 0, 0, 1, 1, 0, and 1, 1. So these 4 states are divided into 2 categories. One is we have seen the assume not taken as a solution, second solution. So in that it is 0, 0 means strongly not taken. 0, 1 means likely not taken. So we use the terminology not taken like NT for shortcuts. Here is likely taken and strongly taken. We use the terminology T, right? So in branch prediction, in dynamic branch prediction algorithm, in 2-bit saturating counters means the algorithm starts with assuming that the branch will not be taken. Branch will not be taken. The first two assumptions. So if there are any two consecutive wrong predictions, then then it changed to taken. So for that, the nodes in this graph that represents the branch prediction and the arrows represents the actual outcome of the branch. So the first 0, 0 means strongly not taken. That we call the branch prediction predicts not taken. If it is 0, 1 means it predicts likely not taken. If it is 1, 1 means it predicts the branch is taken. If it is 1, 0 means branch will likely taken. So this is a hardware prediction or the branch prediction algorithm. The arrows in this graph says that whether actually the branch is taken or not taken during its actual execution. So that means if the branch is not taken and it is assuming that the algorithm assumes branch is not taken, so that remain in the same state, strongly not taken, right? But assuming that the branch is not taken, but actually the branch is taken for the execution, then it change its status bit from 0, 0 to 0, 1. One bit is changed, one wrong prediction. Again, if it is assuming that not taken, but the branch is taken, so there are two consecutive round. This is not taken and not taken, but actually it is taken. Two consecutive wrong. So it will change its status to the 1, 1. Both the bits are changed from 0, 0 to 1, 1. that is strongly taken. But if it is taken, means assume that branch is not taken, but actually if it is taken, then it moves to this state, and further it assumes that branch will not be taken, and actually if it is not taken also, it will come back to the strongly not taken state. If it is in this state and if the branch is actually taken, that will remain in the same state. If it is not taken, it goes to the likely predict taken. And further also, it assumes that it will be taken, but actually not taken, then it goes to the strongly not taken, because there are two wrong. It is assuming that it will be taken, but not taken is one, and assuming that it will be taken, but not taken. So two consecutive wrong, so it reached to 0, 0. If it is at this stage taken, and if the branch is actually taken in the actual execution, then it will go back to strongly taken stage. So this is the overall operation of 2-bit saturating counter in the branch prediction. Yeah. So click on discussion, sorry, and then go to 9.1 class activity, that is 2-bit saturating counter. If you click on that, so here 2-bit saturating counter option is given. The branch actual outcome is given here. Next, we need to predict and update the status bit in this history table. Okay. So, yeah. So there are three columns, and how many rows are there in this 2-bit saturating counter history table? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 rows. So who is going to create this? Dalton or Noah? Yeah, Dalton. Go ahead. Click on the symbol table here, the left side tabs. Okay. Select the table. Yes. Wonderful. Good. Just fill the entries. First, fill the entries. Yeah. Yeah. You both can parallelly do this. Noah, you also create. Dalton, you also create the table. Yeah. Because this activity is recording, so it will be helpful for you also. Both of you create the table and fill the entries in the actual outcome column. This is okay. Is it Noah? Yeah. This one is Noah. This one is Dalton. Yeah. Dalton, you can also create another table. Yeah. Dalton, you also create another table. Let's work together. Yeah. Just fill the entries like Noah, state, me time. This is Noah. Noah. and this one is Delta. If I'm mistaken name, please correct it. Yeah, it's Dalton, right? I guess. Oh, yeah, sorry. Dalton. Yeah, good. Okay. Yeah, now you try to fill. Let me say, yeah, Noah, in the prediction, you have to write taken or not taken. So the algorithm starts with not taken. Two-bit saturating counter algorithm starts with non-taken. The branch predictor predicts with not taken, but actually it is taken. So just wait for another minute. Let Dalton complete. Okay, I wrote wrong mistake. Yeah. Yeah, Dalton, you also parallelly fill your entry in the prediction. So the algorithm starts with, yeah, just fill in this step. Yeah. So the algorithm first starts with not taken and the initial state is 0, 0. Okay. The initial state is 0, 0. So in 2-bit saturating counter, okay. So then compare the not taken with taken. Actually, it is taken, but hardware is predicting not taken. So there is a first wrong prediction, right? So then what will be the state? From strongly not taken, it goes to which state? Go to the graph. Yeah, that's correct. Delta from not taken, but actually it is taken means enters into which state? 0, 1. Perfect. So now the hardware predicts that again the 2-bit saturating counter, second time also it assumes branch will not be taken. Yeah, just type only not taken, Noha. Yeah, not taken, but actually it is taken. So two times this assumption is wrong. So it enters into which state? Wonderful. Dalton enters into which state? Superb. Yeah. So then it changed its prediction from not taken to taken. Wonderful, Noah. Good. Dalton, that's correct. Yeah. Right. So now it goes to which state? Yes. Super, Noah. Good job. Dalton, super, super. I appreciate. Good job. Good job. Next. From taken and not taken, it goes to which state? Dalton. Hmm. Yes, there is a wrong prediction. Wonderful. Noah, good job. Dalton, did you understand that now? Because previous two are not taken. This is one wrong prediction. This is one wrong prediction. This is one wrong plus second wrong, consecutive wrong. So it enters into strongly not taken. Good job. So then what will be the yes, not taken? Super. Good, 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 good. Yeah. Then what's the next status? Hmm, that's great. Noah, yes. Perfect. Dalton, perfect. Appreciate. I'm not taken. It goes to 0. Super. Good job. Please go ahead. Go ahead. Yeah, from not taken, it is not taken. Goes to 0 state. Super. Noah, wonderful job. Dalton, appreciate. Yeah, now please give your comment. You can click on T. Both of you click on T. The text field will be created and give your reflection about this activity. Just type your reflection about this activity. Yeah, you can choose the place anyway. Yeah, you can, know how you can type here. Delta, you can use here. Yeah, let's just delete this. Yeah, text field. Yeah, give your reflection, please. Noah, Delta, even you also. Yeah, click on T, select text field. Yeah, give your reflection. So give your reflection. I'll take 2 minutes break. I'll go and bring my coffee. Please give your reflection. Noah and Dalton, you also create another table, both of you create another table with different actual outcome combinations. Here, in activity, I have given taken, right? But you select yourself, select different combinations of actual output, and then fill it. Not in this table, create another tables, another two tables. Okay. Yes. Good job. Yeah. So delete all this. Let me delete. Dalton, you delete all this. Good job. Okay. And here you select different combinations. Dalton, you also select different combinations and try to fill. And I'm here to see is everything is going on or not. Because this activity is very, very important. You will get at least 40 points in assignment as well as in midterm and final exam. So please go ahead. I'll go and bring my coffee and I'll come back. You can add more rows also if possible. Great job. Great job. Wonderful. Appreciate. Yes. Not taken, not taken. It will remain in the same state. No. And Dalton not taken, but it's taken. It changed room. Correct. Wow. Wow. I really appreciate, and this recorded video will help other students also. This is wonderful. Yeah. So is that makes help? Let me just read out your reflection. Noah says displays the changing state of the prediction depending on what two-bit translate encounter or record and the actual outcome. Yeah. Dalton says the activity helps us understand how a process tries to guess whether a branch. That's wonderful. I really appreciate it. Good job.